Hello everyone, myself Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VNR VIGNANA JYOTHI Institute of Engineering and Technology. Today we learn change of order in double integral. So change of order of integration. So evaluating double integrals by changing the order. Okay. So if the limits of integration in a double integral are constants, if the integral limits are constants, see the even order changing is immaterial. So either first we can integrate with respect to y, then with respect to x, or first with respect to x, then with respect to y. Okay, so constant limits doesn't impact. Even change of order of integration in case of constant limits for both the variables doesn't impact much. But when the limits of integration are variables, that's the case. When the limits for inner integration, anyway both the integral limits will not be a variable. So inner integral limits are, suppose if it is variable limits, then the change in the order of integration will result in the change in the limits of integration. Okay. See, when the limits of inner integration are functions of a variable, that means inner integral limits are variable limits. In such case, if we change the order of integration, which also results in change in the limits of integration. Okay, for this is, you can look into this. It is, suppose if the given integral is in this form, integral c to d, g1 of y to g2 of y, f of x comma y dx dy. It means, see, observe here carefully, the inner integral limits are functions of y. Inner integral limits are functions of y. Nothing but those are x limits. Of course, these are y limits. So if you change the order of integration, that means inner integral limits becomes y limits, outer integral limits becomes x limits. But always we know outer integral limits must be constant limits. So that inner integral limits becomes y limits means those must be functions of x. So this the integral after changing the order of integration, so it will take this form. That is integral a to b h1 of x to h2 of x f of x comma y dy dx. Here observe carefully. Here the inner integral limits are x limits, which are functions of y. Here inner integral limits are y limits, which are functions of x. Anyway, in both the cases, the outer integral limits are constants. Okay, so this process of converting the given double integral into the equivalent another double integral is called the change of order of integration. So now we'll see a problem how to evaluate by changing the order of integration. See, let's see a problem. It is change the order of integration and solve integral 0 to a, integral x square by a to 2a minus x, xy square dy dx. Here we have to evaluate this integral. By changing the order of integration. Observe here. See, inner integral limits are functions of x, variable limits. That means those are y limits. So first we have to integrate with respect to y and then with respect to x. X limits are constants. But we have to evaluate this by changing the order. That means first we have to integrate with respect to x, then we have to integrate with respect to y. That means, so here change of order results in change of limits. So we have to determine the corresponding limits after changing the order of integration, and we have to evaluate the integral. First, let's identify the region of integration. If you identify the region of integration, then it is easy to identify the limits. See, the region of integration is bounded by see, y is equals to x square by a. See, y is equals to x square by a. Okay, y is equals to x square by a and y is equals to 2a minus x. Okay, x is equals to 0, x is equals to a. See here, y is equals to x square by a is parabola. This can be rewritten as, that is, by cross multiplication, this can be written as x square is equals to ay, which is a parabola. It is x plus y is equals to, what is x plus y equals to a, which is a straight line, and x is equals to 0, which is y axis. X is equals to a, which is a line parallel to y axis. Okay, let's identify these in the plane. Let's see the Cartesian plane, xy plane. See, this is x axis and this is y axis I am considering. See, this x square equals to ay is a parabola. X square equals to 4ay. So 4 is not there, which is similar to that. So parabola is this one. X square is equals to 4ay parabola. This is x square is equals to 4ay parabola. This is. So this can be written as y is equals to x square by a. This is the parabola. Okay. And next, x is equals to 0. X is equals to 0 means which is y axis. This is y axis. And next, x is equals to a, which is a straight line parallel to y axis. So here we are having x equals to a. Okay. I'll explain how we are getting this intersection point. And x plus y equals to 2a. So x plus y equals to a is a straight line now. So how to draw this straight line x plus y equals to a? See, let's determine the intersection points of this straight line with the coordinate axis. That is, so x plus y is equals to 2a can be rewritten as, it is a line intercept form, x divided by 2a plus y divided by 2a, which is equals to 1. Dividing the equation with 2a on either side. So 2a. This means that x-intercept is 2a and y-intercept is also 2a. That means that this straight line, what is this straight line? This is x plus y is equals to 2a. This straight line intersect x-axis at 2a comma 0 and y-axis at 0 comma 2a. So these are x-intercept is 2a, y-intercept is 2a. So join these, we get a straight line x plus y equals to 2a. And this is x is equals to 0. So this is x is equals to 0. And here this is the intersection point. No, this is the intersection point of the parabola and the line x plus y equals to 2a. First, let's determine the intersection point. Okay. See, substitute. So put y is equals to 2a minus x. Y equals 2a minus x in y is equals to x square divided by a. That is, if you substitute what we get, it is 2a minus x is equals to, it is x square divided by a. It means, let's do cross multiplication. X square equals to, it is 2a square minus ax. Now, this is x square plus ax minus 2a square is equals to 0. Which is a quadratic equation? Which is a quadratic equation. Let's determine the roots. So it is in the form a equals to 1. We use the formula x equals to b square minus b plus or minus square root of b square minus 4ac by 2a. So b equals to a. So minus a plus or minus root over b square a square minus 4ac. 4 a equal to 1. C equal to minus 2a square. Minus to minus plus 4 to ja 8. So it is 8a square divided by 2a. 2a means 2 into 1, which is 2. Therefore, it is x is equals to, it is minus a plus or minus root. This is root over 9a square, no? Root over 9a square divided by 2. This means, let's see here, simplifying further. So x is equals to, it is minus a plus or minus root over 9a square is, it is 3a divided by 2. So that is x is equals to, one is minus a plus 3a divided by 2 is one value, minus a minus 3a divided by 2 is the another value for x. So x equals to, this is plus 2a by 2, which is a. This is minus 4a by 2 is minus 2a. So x is equals to a comma minus 2a. X equals to a comma minus 2a. So this parabola intersect at x is equals to a and minus 2a. Minus 2a is lies in, x equals to minus 2a lies in second quadrant. Okay, x equals to, and this intersection point. Here we have another intersection point of this line with the parabola, no? Here the x coordinate is minus 2a. This is not our interest. Since the region of integration here only in the first quadrant, let's leave this point minus 2a. Okay, only consider x equals to a. So now for x is equals to a, what is the corresponding value for a? Y. It is put x is equals to a in y equals to 2a minus x. That is y equals to 2a minus a. That means y is equals to a. So this is the intersection point. So a comma a is the point of intersection, is the point of intersection with parabola in first quadrant. Since our interest only in first quadrant. Okay. So this is the point of intersection. So a comma a. Observe here now x equals to a means this is the line now x equals to a. As we know that x equals to a is a straight line which is parallel to y-axis. Now identify the region. So region is bounded by x is equals to 0 and x equals to line. So area lies between these two lines only. So therefore region lies only in the first quadrant. Next, and the region is bounded by this line and this parabola. So this is the region of integration. Is the region of integration. So now observe carefully the given limits. Inner integral limits are functions of x. As we discussed in the last class, inner integral limits are functions of x means those are y limits. Those are obtained by considering the vertical strip in the region. Observe carefully here. We have a vertical strip in the region. We have vertical strip here. See here, vertical strip in the region. So where the strip has its ends, lower end of the strip is moving on the parabola. That is y equal to x square by a. That's why see here, lower limit is x square by a. Upper end of the strip is moving on the straight line x plus y equal to a. So you have to express y in terms of x now. So y equals to 2a minus x. So upper limits are 2a minus x. So these are the ends of the strip moving on the curves y equal to x square by a and y equal to 2a minus x. So these are inner integral limits, y limits which are functions of x. So to cover this region, this strip has to slide from the line x is equals to 0 to x is equals to a once to cover the entire region of integration. That's why those are the outer integral limits. So these are the original limits. Our interest here is to change the order and we have to evaluate the integral. Okay. So now on change the order of integration, that means remove the vertical strip from the picture and instead of that consider horizontal strip and determine the corresponding limits and evaluate the integral. Remember, changing the order of integration means changing the strip in the region. In the simple way you can understand. Okay. Let's see by considering horizontal strip. Okay. Identifying the limits. Let's see. See the same region I am considering as only the first quadrant. No, the limit region. See, this is the region. This is the line x is equals to 0 y-axis, and as we know that this is the line x equals to 2a minus y, or actually x plus y is equals to 2a. This is the line actually, and this is the parabola. As we know that x square equals to ay. X square equals to ay. Okay, and this is the intersection point a comma a. So remove the vertical strip, consider the horizontal strip in the region. See here, we have considered two horizontal strips in the region. Why? That is important. See, if you consider generally a strip in the region, the strip has to move only on the two curves, lower end and upper end throughout the region. But here what is happening if you consider a horizontal strip in the region, say, let us consider a horizontal strip like this. What happened? Let us consider a horizontal strip in the region. See, let us consider a horizontal strip in the region like this. Okay. Okay. See now, what is the left end of the strip? Left end of the strip is moving on x is equals to 0 throughout the region. But whereas if you look at the right end of the strip is moving on this straight line up to some extent. But after that, it is moving on to the curve. So that the horizontal strip, if you consider, it is changing its right end from straight line to parabola. That's why we have to divide the region into two subregions, that is say R1 and R2, and we have to consider two horizontal strips separately, and we will get the limits also in two regions separately, and we evaluate the two double integrals. Okay, so this is, let us assume it is region 1 and this is region 2. Okay, let's identify the limits for region 1 and region 2 separately. Okay, so now let us consider that region 1. See, vertical, we removed vertical strip, we are considering horizontal strip. Horizontal strip means x limits are functions of y. Inner integral limits are x limits which expressed in terms of y. So that is, observe first region 1. This is region 1. See, left end of the strip is moving on x is equals to 0. So therefore, x varies from 0 to, okay, right end of the strip is moving on parabola. Remember, we have to express x in terms of y. So that's why this x square equals to ay parabola is expressed as x equals to root over ay. So therefore, right end of the strip is moving on root over ay. So x varies from 0 to root over ay. This is inner integral limits. Now let's coming to outer integral limits. Y varies from, to cover this region, this strip has to slide once from the line y is equals to 0 to, this is the line y is equals to a. A line which is parallel to x-axis means y is equals to constant. On this line, observe carefully, here the y coordinate is a now. So on this line, this line represented by y equals to a. Okay. So therefore, y varies from 0 to a. 0 to a. This is region 1 limits. Similarly, let's identify region 2 limits. Now coming here. See, here also we are considering another horizontal strip. Left end of the strip is moving on the line x is equals to 0. So x varies from 0 to, right end of the strip is moving on the straight line x plus y equals to 2a. So express x in terms of y. So x is equals to 2a minus y. That means x varies from 0 to 2a minus y. And y varies from a to 2a. See here. Here this strip has to slide from the line a to y equals to a to, here the coordinate is, y coordinate is 2a, no. So therefore this line is y is equals to 2a. So this strip has to slide from y equals to a to y equals to 2a once to cover the region of integration, that is R2. So these are the x and y limits for both region R1 and R2 separately. Let's evaluate the integral in region 1 and region 2 separately. See, what is the given integral? This is. Let's rewrite once this one. So that is, now consider, see, double integral 0 to a integral x square divided by a to 2a minus x xy square dy dx. This is the given, which is equivalent to, okay, on changing the order of integration, okay, on changing the order of integration, we get, this is in double integral over the region R1, it is xy square dy dx plus double integral over the region R2, xy square dy dx. Okay, not dy dx. So after we change the order of integration now, that's why it is dx dy we have to write. Write it as dx dy. So it is dx dy. Dx dy. Okay. Now we let us take it as an equation number 1. Okay. This is on changing the order of integration. On changing the order of integration, we get this one. So we evaluate our double integrals, these two over region R1, R2 separately. Okay. So now consider, we'll do one thing. Remove this one. On changing the order of integration, we get this. Let's consider first evaluating double integral over the region R1 xy square It is dx into dy. That is equals to integral. So what are the limits in the region R1? It is y limits are constants 0 to a and x limits are 0 to root over ay. It is xy square into dx into dy. Let's evaluate. So first inner integral limits are functions of y which are x limits. First we have to integrate with respect to x by treating y as constant. So let's take y as constant. So y square is constant. Integral x into dx. What is integral x dx? X square divided by 2. X square divided by 2. What is the limits for? Upper limit root over ay, lower limit 0 into dy. Now this is equals to integral y is equals to 0 to a. Now it is y square into, let's substitute the limits. Upper limit is root over ay. Root over ay, instead of x we have to substitute since we integrated with respect to x, no? Root over ay whole square. Root over ay whole square divided by 2 minus substitution of lower limit 0. No contribution. Instead of x 0. So it is dy. And next this is equals to. This is now integral y varies from 0 to a. It is root over ay whole square is ay. It is ay. So therefore it is a y into y square y cube divided by 2 into dy. Dy. Now this a is constant and 2 is constant which can be written outside of the integral and integrating with respect to y. Y cube, integral y cube dy. Y cube dy means y to the power of 4 divided by 4. Upper limit is a, lower limit is 0. So therefore this is equals to a by 2. Instead of y substitute a. So a power 4 by 4 minus substitution of lower limit instead of y 0. No contribution. So it is equals to a to the power of 5 divided by 8. So this is, let's take it as an equation number 2. This is double integral over the region R1 xy square dx dy. Xy square dx dy. Okay. Let's evaluate the integral over the region R2. Over the region R2. See this is. That is now consider double integral over the region R2 xy square dx into dy which is equals to integral. See here R2 limits are considering vertical strip or horizontal strip. Left end of the strip is moving on x0, x equals 0. Right end of the strip is moving on x equals to 2a minus y. To cover the region, this strip has to slide from the line. Y is equals to a2, y is equals to 2a, this line. Okay. So therefore y varies from a to 2a and x varies from 0 to 2a minus y. It is xy square into dx into dy. Now let's simplify. First integrating with respect to x since x limits are functions of y. So we are integrating with respect to x. We treat y as constant. So y square is constant. Integral x into dx. Integral x dx is x square divided by 2. Upper limit is 2a minus y. Lower limit is 0. Next with respect to y. This is integral y is equals to a to 2a. Now let's simplify. This is y square. Instead of x we have to substitute 2a minus y. It is 2a minus y whole square divided by 2. Lower limit is 0, no? It has no contribution. So dy. This is equals to, now it is, let's write this 2 outside. 1 by 2 integral y is equals to a to 2a. Now let's expand this form a minus b whole square. A square is 2a whole square, that is 4a square. So let's write it as 4a square into y square. Next minus 2ab. Minus 2ab means 2 2s are 4, 4ay. 4ay. So therefore 4ay into a square. 4ay cube plus b square. Plus b square means y square into y square which is y power 4 into dy. Now this is equals to 1 by 2. Now integrating with respect to y. It is 4 a square constant. Y square integral is y cube divided by 3 minus 4a into y cube integral is y power 4 divided by 4 plus y power 4 integral is y power 5 divided by 5. Whereas upper limit is 2a and lower limit is a. Now this is equals to 1 by 2. Let's simplify this. Instead of y, we have to substitute 2a and a. That is, it is 4a square into y cube. 2a cube is, we can write it is 8a cube divided by 3 minus, it is this 4 and this 4 cancel. A into y power 4, that is 2 power 4 by a power 4, it is 16a power 4. Next plus, instead of y, 2a, it is 32a to the power of 5 divided by 5. Minus substitution of lower limit, it is 4a square into a cube divided by 3. Next, my substitution of lower limit, so minus into this minus becomes plus. It is a into a power 4. So a into a power 4. Next, substitution of lower limit minus, it is a to the power of 5 by 5. Let's simplify it further, which is equals to, it is 1 by 2. Let's simplify. 8 4s are 32. So it is 32a to the power of 5 divided by 3. Okay. Minus 16a power 5. Okay. Next plus 32 divided by 5a power 5. Next minus 4 by 3 a power 5. 4 by 3 a power 5. Next plus, it is a power 5. Next minus a to the power of 5 by 5. So therefore this is equals to, a power 5 is common in every term. Let's take it common. A power 5 divided by 2. And let's take LCM. It is 5, 3. Let's take it is 15 is the LCM. 3 5s are. So 32 5s are. It is 160. Next minus 16 15s are. 16 15s are. It is 240. 240 plus 5 3s are. So 32 3s are. It is 96. Minus 3 5s are. 5 4s are. Plus 1 15s are. So plus 15. Next minus 5 3s are plus 3. Minus 3. This is equals to, now let's simplify. It is a power 5 divided by 30. Now 160 minus 240, it is minus 80 plus 96. So plus 16 minus 20 minus 4 plus 15 plus 11 plus 11 minus 3 plus 8. So therefore it is 2 4s are 2 15s are. 4 by 15 a power 5. So this is, let's take it as an equation number 3. So now we evaluated integral in region 1 and region 2 both. Okay. Let's substitute this equation 3 and this equation 2 both in equation 1. Okay. Let's see substituting these. Now substituting 2 and 3 in 1. So therefore integral, it is 0 to a integral x square divided by a to 2a minus x. Okay. xy square dy dx. xy square dy dx is equals to, what is it? 2 a power 5 by 8. A to the power of 5 divided by 8. Next, it is 4 by 15 a power 5 plus 4 by 15 a power 5. So now let's take LCM. It is, let's take it is 120. It is 15 a power 5 plus 32 a power 5. That is 47 divided by 120 a to the power of 5. So this is, so now like this we change the order of integration and we evaluate the integral. Okay, just we'll see once. See now, this is the region double integral given. Inner integral limits are functions of x. So which are y limits? Nothing but these are obtained by considering a vertical strip in the region. That is, lower end is moving on parabola, upper end is moving on the straight line. To cover the region, it is sliding from x0 to xa. Okay. Now identify the region and determine the intersection point of the straight line with the parabola. Okay. Now remove the vertical strip in the region by changing the order and consider a horizontal strip. Since the horizontal strip, if you consider, it is moving on two different curves, so that's why we have to divide the region into two regions, R1 and R2 separately, and identify the limits for R1 and R2. R1 horizontal strip, left hand moving on x equals 0 and right hand moving on parabola x equals root ay, and to cover the region, it is sliding from y0 to ya. And in the region 2, x equals 0 to a minus y, and cover the region y equals to a to 2a. Let's evaluating the integral, this equivalent of, on changing the order of integration. This double integral is equivalent to these two, sum of these two integrals. Let's evaluate these two separately. Okay, so first it is y square, a square, x square by 2. And so on simplification, we obtain it is a power 5 divided by 8. This is, let's take it is 2, and evaluate in the region 2. It is first with respect to x, since it is inner integral limits are functions of y. Let's treat y as constant. It is x integral is x square by 2. Let's substitute it is 2a minus y. Lower limit has no contribution. Minus it is a square minus 2ab, which is 4ay into y square plus y power 4, and integrating this and substituting the limits, upper limit and lower limit, and simplify. Okay, we obtained 4 by 15 a to the power of 5. Okay, so, and substituting this equations 2 and 3 in equation 1, we got the answer, that is 47 divided by 120 into a to the power of 5. Okay, so now we'll see one more problem. See, this is change the order of integration and solve. See, we change the order of integration, we study only for Cartesian coordinates. Okay, so not polar, only for Cartesian coordinates we'll study. Now change the order of integration and solve. Integral 0 to b and integral 0 to root over a into root over b square minus y square divided by b xy into dx dy. See here, the region of integration is bounded by, see, okay, region is bounded by, inner integral limits are functions of y, those are x limits. So x is equals to 0 and x is equals to a into root over b square minus y square divided by b. Okay, y is equals to 0 and y is equals to b. That is, so x is equals to 0. Okay, what is this? Let's simplify this one. It is bx equals to a into root over b square minus x square, sorry, b square minus y square. Now squaring on both sides, so it is b square x square equals to a square into b square minus y square. Okay, now it is b square x square is equals to a square b square minus a square y square. Let's bring this variable term to left hand side. So a square y square plus b square x square is equals to a square b square. Let's dividing on both sides with a square b square. So a square y square divided by a square b square plus b square x square divided by a square b square, which is a square b square by a square b square is 1. This means a square cancel, b square cancel. So which is x square by a square plus y square by b square, which is equals to 1, which is actually an ellipse. Which is actually an ellipse with center at origin. So here let's draw the figure. It is ellipse with center. Okay, and major axis length is 2a. So therefore this is, let us assume here it is a comma 0 positive side, and say this is minus a comma 0 on x-axis, and say this is 0 comma b, and say this is 0 comma minus b. Okay, okay, let us take this is an ellipse. Okay, and see, the region is bounded by, observe carefully, region is bounded by x0. x0 means x is equals to 0. X is equals to 0 means y-axis. Y is equals to 0 means x-axis. Y is equals to b means is a line parallel to x-axis. This is the line y is equals to b. And ellipse. X is equals to this one. Ellipse means this is. So means the region of integration is only in the first quadrant. This is the region of integration. So is the region of integration. This is the region. Now, so actually the original is inner integral limits are functions of y. That means original limits are obtained by considering a horizontal strip in the region. So inner left end of the strip is moving on x equals 0. Yes. Or right end of the strip is moving on the parabola. That is x equals to this. And to cover the region, this strip has to slide from the line y is equals 0 to y equals to b, outer integral limits. Okay. But here we are changing the order of integration. So we have to remove the horizontal strip from the picture. Consider vertical strip in the region. I am considering the vertical strip now. Vertical strip, I am identifying it with green color. Okay. Now identify the new limits. New limits I am writing with green color. So therefore, lower end of the strip is moving on y is equals to 0. Upper end of the strip is moving on the parabola. So parabola is x square by a square plus y square b square equals to 1. Express this as y in terms of x. Y in terms of x is equals to, this is y is equals to, see, bring this x square by a square to other side. So this can be, I'm writing here. So it is y square by b square is equals to 1 minus x square by a square. Now this can be written as y square is equals to, by cross multiplication, it is a square minus x square divided by a square into b square. Okay. Therefore, what is y now? Y is equals to root over, no? Root over b square means b. Root over a square minus x square divided by root over a square is a. So this is y equals to b by a root over a square minus x square. Y varies from. Now, on changing the order of integration, on changing the order of integration, so we get y varies from 0 to, it is b by a root over a square minus x square. And to cover this region, x has to slide from the line x is equals to 0 to, this is the line x is equals to a. That is, to cover the region, this strip has to slide from the line x is equals 0 to x is equals to a. So these are the now new limits. X varies from 0 to a and y varies from 0 to b by a root over a square minus x square. Let's evaluate the integral. So therefore now the integral, double integral 0 to b, integral 0 to a root over b square minus y square divided by b, it is xy dx dy is equivalent to integral x varies from 0 to a, integral y varies from 0 to b by a root over a square minus x square into xy dy dx. Let's evaluate this integral. Now, see, this is first integrating with respect to y, no, we treat x as constant. So therefore, this is equals to integral x varies from 0 to a, Now, we treat x as constant, no? So therefore, x constant. First integrating with respect to y, integral y dy is y square by 2. Y square divided by 2. What is upper limit? Upper limit is b by a root over a square minus x square. Lower limit is 0 into dx. Let's substitute the limits. Integral x varies from 0 to a. Instead of y, so this 2 1 by 2 can be written outside. So x into, instead of y, substitute this. That is b square, y square. So it is b square by a square. Root over a square minus x square whole square becomes a square minus x square. Minus substitution of lower limit, it is 0, no contribution. This is equals to x. 1 by 2, integral x varies from 0 to a. Now, and this a square also we can write outside. So this b square also, so b square by 2a square. It is now a square into x minus x cube into dx. Now, integrating with respect to x, b square divided by 2a square, integrating with respect to x, a square, x integral is x square divided by 2 minus x cube integral is x power 4 divided by 4, upper limit a, lower limit 0. This is now b square divided by 2a square. Let's substitute a square into, instead of x a, it is a square divided by 2 minus a power 4 divided by 4. Substitution of lower limit 0, 0, no contribution. That is, this is equals to, now it is b square divided by 2a square. Let's simplify. This is a to the power of 4 divided by 2 minus a power 4 divided by 4. Now this is b square divided by 2, a power 4 common and gets cancelled. So it is 1 by 2 minus 1 by 4. Okay. This is a square b square divided by 2 into 1 by 2 minus 1 by 4 is 1 by 4. Therefore, it is a square b square divided by 8. So this is on evaluating the integral after changing the order of integration. Okay. I hope you understand. So work out these two problems, change the order of integration and evaluate. And here evaluate the integral by change the order of integration. So here in both the cases, of course, the inner integral limits are functions of x. So that is both are y limits, and outer integral limits are constant limits, which are x limits. So try to work out these two problems. Okay. Thank you. If you have any queries, feel free to contact me over the mail, pavankumarreddy_m@vnrvjit.in. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.